In this video, we're going to look at the binomial theorem and look at some ways that we can expand using the binomial theorem and then a shortcut method. Let's look at the binomial x plus y to the 0. And that gives us 1. X plus y to the 1 power is x plus y. To the second, x squared plus 2xy plus y squared, and so on. X plus y to the third. Get x to the third plus 3x squared y plus 3xy squared plus y to the third. And then you have x plus y to the fourth. And I want you to note that you look at the power of the binomial and the number of terms on the right side are one more than that. So the first one has the power of 0. 0 plus 1 is 1. We have one term. The second one, power of 1. 1 plus 1 is 2. We have two terms. This one has power of 2. On the right, we have 3 terms. A power of 3. On the right, we have 4 terms. A power of 4. On the right, we have 5 terms. That's the expansion for the binomial. Also note, let's look at x plus y to the third first, that the power of the x term, or that's the first term, decreases by 1. So notice it's x to the third, x to the second, x to the first, and then in the last term it's x to the 0. And then the second term, or the y in this case, starts at y to the 0 in the first term, then it goes to y to the first. It increases, and then it increases again, y to the second, and then y to the third. So the power of the first term, in this case x, decreases by 1 until it goes to 0. And in the first term, the power on the y increases by 1 until it gets to whatever the power is in the binomial, in this case a 3. So notice that if you look at this, every term of the expansion is going to have both terms, the x and the y, except where the power is 0. So in the first one, the exponent on the y is 0, so it doesn't show. Y to the 0 is 1, so you can say 1 times x to the third is x to the third. And in the last term, it's x to the 0. So that's 1, you get y to the third. So notice the exponents always add up to whatever the power is. In the first one, it's 3 and 3. Second one, 2 and 1 is 3. In the third term, 1 and 2 is 3. And in the last term is 3. Also note that the first term of the expansion is always the first term taken to whatever power you're dealing with. So x to the third gives me the first term. The last term is always the second term taken to that power. So in this case, y to the third. So again, emphasize, if it's to the nth power and the number of terms on the right is one more than that, or n plus 1. So if I were to give you, say, x plus y taken to the 50th power. They ask you the first term. They ask you for the first term of this expansion. We should know that the first term is always what it is, taken to that power. So that's x to the 50th. If they ask you for the 51st term of this expansion, what's the 51st term of this expansion? Well, 51st is just another way of saying the last term. So we already know that the last term is going to be the second term taken to that power, so that's going to be y to the 50th power. So sometimes in this you might have to expand a binomial, or the question might be find a specific term, find the third term or the fifth term of the expansion without expanding. Well, they might ask you to expand it. Depends. So let's say expand this. Let's say we look at x plus y to the 5th power. And we say expand this. We could do something like this. Just say it's going to be x. We know the first term is going to be x to the 5th, and we know there's going to be 6 terms on the right side of the expand. 6 terms in the expansion, or on the right side. So it's x to the 5th. We know that's the first term. And then the next term, the power on the x will be 1 less than that. So subtract 1 from 5, this will give us 4. And remember, the first term doesn't have the second term there, the y. So the power is 0, so the exponent of the y increases by 1 as we go from left to right. So this would be a 1. Plus, and then the next term, the pattern is the exponent on the first term of the x decreases. So that's x to the third. On the y it increases. So we get that. And let me just string it over here so it fits. The next term then should be x to the second. The y exponent increases. So that's the third power. And the next one should be an x with smaller exponent by 1. So this would be 1. And on the y it increases. Plus. Next one. So we check this. 5 on the x. 5, 4, 3, 2, 1. And then it's x to the 0. On the y it's y to the 0. And then it's 1, 2, 3, 4, 5. Those would be the terms missing the coefficients. Now there are several ways to get the coefficients. One is to use Pascal's triangle. And you can just keep going on this. The first one has a 1, that would be to the 0 power, 1 term. And then the next row would be to the first power. Coefficients would be 1 and 1, so you have 1 and 1. And then the second one, the square, has the 3 terms. Coefficients, you can see here 1, 2, 1, and then the row would be 1, 2, 1. And then for the cube would be the next row. You can see the coefficients 1, 3, 3, and 1. You have 1, 3, 3, and 1. And you can keep on going. So you see, I would have to have 2 more rows to get the coefficients of this. So that's one way to do it. But I like to use this method here. Which is really derived from the binomial theorem, which we'll look at in a minute here. But this is the method that I want to show in this video. That's the main thing here. We got the terms missing the coefficients. So here's the way it works. Start with the first term. And say 5 times, whatever you have there, it's a 1. Answer to be 1. So it's 5 times 1. And then divide by the position of that term. 5 divided by 1 is 5. So that comes over to the next term. And then we go 4 times 5 is 20. Divide by the position of that term. That's the second term, so 20 divided by 2, that's 10. So this would be a 10 here. And then we just repeat it. 3 times 10 is 30. That's the third term. Divide 30 by 3. This will be 10. That's the coefficient. And there we go again. 2 times 10 is 20. 2 times 10 is 20. Divided by the position, that's 4. This would be a 5. The next one, again, repeat the procedure. It's the exponent of the first term. So it's x to the first here, so it's 1 times 5. It's 5. That's the fifth term. 5 divided by 5 is 1. So that's the expansion of that binomial using this technique. Like I said, you can use Pascal's triangle. And then with Pascal's triangle, if you have a high power like a 7 or 8, then you have to go through that many rows. That's all there is to this one. Again, emphasize. Again, what we have over here, the first term of the expansion is always the first term of the binomial taken to that power, whatever it is. In this case, 4. We're looking at this one here. The last term, in this case, y, taken to the 4th power, y to the 4th. And there's always one more term than you have in the exponent for the binomial. Now, the binomial theorem is this right here. X plus y to the n. And notice it just gives you the pattern. X to the n. The next term has x to the n minus 1, x to the n minus 2, x to the n minus 3, and so on up until the last one. And all it's doing is decreasing the power on the x, or the first term of the binomial. And for the first one, notice it starts at I equals 0. So the y would be y to the 0, which is 1, so it doesn't appear. But then it increases. You're adding 1 every time. So the second term goes y to the first, y to the second, y to the third, all the way up to y to the n. And this is an important term here, because this allows you to find any particular term of the expansion without having to expand it. In other words, say you have something to the 50th power, and they want you to find the 7th term, or the 8th term. You don't want to have to go through and expand it all and then count up until that term. Don't want to do that. The only other thing I want to go over here for this part is that the ni here, notice n0, n1, n2. This is also another way to compute the coefficients. So this is saying, okay, if n is 5 and we're looking at, say, 3, this, sometimes this is written as, so that's what this formula means here. So nr, or sometimes cni. Factorial just means, let's look at 3 factorial. That means the product of integers from 1 to whatever n is. In this case, it's 3. So we can go this way, 3 times 2 times 1, or you can start with a 1 first and go to n. 1 times 2 times 3. This, of course, is going to be 6. In this case, and then the I factorial in this case is 3, so this would be 3 factorial. So we can break this down this way, 5 times 4 times 3, all the way down to 1, but that would just be, this part would just be 3 factorial. So this one and this one would cancel out. And then 2 factorial is 2. 2 into this is 20 would be 10. So you get this equal to 10. Now you can also use your calculator to compute this if you have large values. Go to math. Let's first enter the 5. You want to compute, say, 5, select 3. Combination is 5 things taken 3 at a time. Enter the 5 and then go to math. Over to probability. And then number 3 is the formula we want. Enter the 3 now. And that gives us 10, the same thing. So that's another way to do it. Let's suppose, instead of using the formula, which we can get it, let's suppose you wanted to compute this out. X minus 2y to the 5th power, using what we've already talked about here, and not having to apply the actual binomial formula. So here's what works. Set it up like these over here. So notice I have x minus 2y to the 5th. All these have pluses. Makes it convenient. So I just rewrote x minus 2y to the 5th. And I wrote it as x plus negative 2y in parentheses taken to the 5th power. So just look at this as x is x, just like in these over here. But instead of just having a y by itself, we have negative 2y. So here's the way it works. The first term of the expansion is the first term of the binomial taken to whatever power. In this case, it's 5. There it is. And the minus 2y doesn't appear for that one. It appears in the second term because, remember, the first term is exponent of 0. And then look at the powers. On the x, we go from 4 to 3, and then to 2, and then to 1, and then on the last term, it's x to the 0, which is 1. So that's why it doesn't appear. But on the second term, which in this case is minus 2y, exponent there, the first term is 0, but then it goes to 1 here, and then to 2 here, and then to 3, and then to 4, and then the last term, which would be the 6th term of the expansion, is 5. That's the way we would have, instead of running it out 5 factors of x minus 2y and multiplying 2 at a time. There it is. All we need is the coefficients. Here's a technique that you can use that will work. Instead of using the binomial formula, just go like this: 5 times 1. Exponent on the x term is 5 times the coefficient here right now. I just have to be 1, so it's 5 times 1 is 5, and that's the first term. 5 divided by 1. That's going to be the coefficient for that one. I'll just leave it like that for now. And then we go to the second term. It already has this coefficient. Now, obviously, that's going to change because this one has a -2. Okay, ordinarily these over here just have x and y. But it's okay, we'll do that later. So now here we're going to go 4 times 5. 4 times 5 is 20. And that's the second term. 20 divided by 4 times 5, that's 20. And that's the second term. 20 divided by 2 is 10. So this is 10 here. Now we need to term the coefficient for the next term, which would be the fourth term. Same thing. It's not the exponent of the second term, exponent of the first term, in this case x to the third, so it's 3 times 10 is 30. 3 times 10 is 30. And that's the third term, so 30 divided by 3 is 10, so this is 10. Same thing, look at the exponent on the x for this term, and say 2 times 10 is 20. That's the fourth term. 20 divided by 4 is 5. So now we just need the coefficient for the last term. So the exponent on the x is 1. 1 times 5 is 5. That's the fifth term. 5 divided by 5 is 1. So that one just stays 1. So again, just to confirm that you got this, it's 5 times 1 divided by the position of that term, which is the first term. 5 divided by 1 is 5. It gives me the coefficient for the second term. Then 4 times 5 is 20. Position of that term is 2. 20 divided by 2 is 10. I got the coefficient for the following term. Then 3 times 10 is 30. Divided by, that's the third term, 3, I get 10. And then 2 times 10 is 20. Divided by 4, that's 5. Okay? And then 1 times 5 is 5. That's the fifth term, so 5 divided by 5 is 1. And those are the coefficients. Now all you have to do, of course in this case, because you don't have a plain y, you have a -2, you're going to have to deal with that. So it's obviously going to be x to the fifth. And then here it's -2 times the 5. That's going to give me a -10. And of course the x to the fourth is there. And of course you have the y. Have a plus. Go to the next one. So for this one then, you see you got x to the third, so bring it down. X to the third, and then you got to square this out. So y squared will give me the y squared. And then the coefficient is 10. Well, it's -2 squared, so that's 4. So this will be a 40 here. Okay, then we go to the next one. Be a plus here. Leave this plus out because it's going to change. The sign's going to change because of the -2 there, and it's an odd power. So this will be actually going to be a minus here because we have y to the third and the x squared, so x squared is going to stay. Y to the third. So this is going to be -2 to the third here. Just doing the calculations here. It's -8 times 10. So this will be a -80. And then we go to the next one. This will be a plus. This is going to be x, and then this is going to be to the fourth power, so the y will be to the fourth power. X y to the fourth, and then -4 to the fourth, that's a +16. And the coefficient we got was 5, so this is 80. And then the last one, odd power, so this will come out to a minus. Coefficient is 1, so it's minus 2 to the 5th. It's a 30, minus 32. Y to the 5th. So that's the expansion. So again, to get the main part of the term, we just use the fact that the exponent on the first term increases or decreases, I'm sorry, by 1 all the way to the end. And on the second term in that first position, the exponent increases. So we go x to the 5th, then x to the 4th, to the 3rd, to the 2nd, to the 1st, and then to 0. And on the minus 2y, it increases from 0 to 1, to 2, to 3, to 4, all the way to the last term, which is 5. Now we can also use an abbreviated form of the binomial theorem to find a particular term. They give you an expansion and they say without expanding, find the 4th term, find the 9th term, find the 15th term of the expansion. That's coming up later. But thanks for watching. We'll see you next time.